Good morning, students. Myself, Dr. S. Vidyanandani, Assistant Professor, Department of Mathematics, SRM-ST Katangulathur. Yes. Now I am going to take Unit 1 from Advanced Calculus and Solid Geometry. Advanced Calculus and Solid Geometry. Yes. Under this, Unit 1. So I am going to take Unit 1, so-called multiple integrals. So I'm going to take multiple integrals. Some few problems I'm going to cover under this multiple integrals. For this, the basic thing you have to know is the double integral and triple integral. Double integral. So double integration dy dx. Or what is the other way of integrating this double integral? So yeah, actually f of x comma y should be there. So r function of x comma y dy dx or dx dy. So this is so-called double integration. This is a respective function. Whenever your function depends upon two variables, so we have to use this double integral. Since the function depends upon two variables, so we have to integrate this function f of x comma y with respect to x-axis and then with respect to y-axis. Okay, any functions exist here now. So we have to expand this function and we have to find the required area for this function with respect to x-axis and with respect to y-axis. So how to integrate? Take any function here. So first, initially we have to integrate along, the function moves from this end to this end. So first we have to integrate with respect to x. So this is inner integral and this one is outer integral. So inner integral we have to integrate. Suppose if I consider this function, we have to integrate along x-axis as first, keeping what as constant? Keeping all the moments along y as constant. So we have to integrate. So we'll get one function. So later we have to integrate with respect to y. So you will get some function. So later we have to integrate with respect to whom? With respect to y. Right. So we'll get the respective area for this function with respect to x-axis and y-axis. Similarly, triple integral. So next we am going to give the formula for triple integral, which is the very basic for this multiple integrals. So triple integral. So you have to understand here the limits may be constant or variable. Like limits of x can be constant. So like c1, c2. Like limits of y, limits of x also can be a constant like c3, c4. Okay. So it can be constant or otherwise it can be variable also. Specifically for inner integral, one can be constant, the other can be variable, or the other can be constant, the first means lower can be constant, the upper can be variable. In such a way you can see the things like right, like triple integral. What is the formula for triple integral? Triple integration function of x comma y comma z dz dy dx, dz dy dx. Right. So first we have to integrate. So this is a function given. When to use this triple integral? As I told you, when we have to use this double integral, whenever your function depends upon two variables, we have to use this double integral, like circle equation. When to use this triple integration? Whenever your function depends upon your scalar function or any your surface depends upon three variables, x, y, and z. Okay, whenever your function depends upon three variables, imagine a sphere. So we can find immediately we can find the volume of those function. Okay, right. So first we have to integrate with respect to whom? Z test first. We have to integrate with respect to z. Okay. So limits may be, as I told you, limits may be constant or variable. So it can be anything. First we have to choose the inner integral and then find the value, either in terms of any function you will obtain. So later we have to use this middlemost axis, like y-axis, middlemost integral we have to supply, and then we have to integrate. We will get some function. we'll get some function value. Later, as at last, we have to integrate that function with respect to whom? X. The outermost axis and outermost, I mean the outermost integral, you have to expand and then you have to integrate. You have to integrate the outer. So you will get the final volume of this whole sphere. Okay. So with this information, I'll go for the problem. So what is the problem here? Like evaluate. So this is the problem. Straight away, I'll take you to the triple integral as first. Evaluate triple integral x plus y plus z dz dy and dx. Evaluate this. Evaluate this function. Right. So what is the limit given? So no issue here, it seems, because all upper limit and lower limit are constants here, a, b and c. So this is the problem. So let us integrate the function. So first of all, we have to integrate the inner, as I told you, inner function. So this is the respective function of x comma y comma z. So first and foremost, we have to choose the inner integral. So 0 to a, 0 to b. What is integration of dz? X is a constant. Actually speaking, as I told you, whenever we are integrating with respect to z, we have to make the other as constant, other points along the axis as constant. Like these are all constant, these are all constants. So we have to see only the points moving along the y-axis. So what happens here? So since we are integrating with respect to z, x should be what? Constant. So keep x as it is, and then so integration of this one was integration of dz is z, right? What is the limit? Lower limit is 0, upper limit is c. So plus y. So y into what? Y into z. So what happens? So y into z. So lower limit is 0, upper limit is c later on. So what is integration of ez? Actually, z is the variable here. So obviously, I have to integrate that. So I'll get z squared by 2. So limit is 0 to c, right? So whole thing into the outermost two axes are available here, dy, dx. Okay, so close the bracket. Now, so we shall supply the upper limit and lower limit here. So 0 to a, 0 to b, x into c plus y into c plus z square. So c squared by 2. So whole thing into dy dx. So second choice, we have to integrate with respect to y-axis. Where is our y-axis? Here. So with respect to y-axis. So what do you mean by this? With respect to y-axis, I have to see the moment, keeping the other two moving point is constant, axis is, other points along the other axis is constant. So what happens? Let us look into it. So 0 to a, integration of xc into y. So xc, since x is constant, c is constant, as I told you, so integrating with respect to y. So I'll get 0 to b. Plus here I think I have y is available, so c is constant, take it out. So y squared by 2, 0 to b. Plus c squared by 2 into y. So y means what happens? 0 to b. So whole thing multiplied by, the last axis is x. So I took that out. Coming to the other part. So here 0 to a, x into c, upper limit is b. So b minus 0 is b. Plus c by 2. What is b square? Y square means substitute y as b. I'll get b square. Plus c squared by 2 multiplied by whom? B. B minus 0 is b. So the whole thing into whom? Whole thing into dx. Okay. Right. So now I have to integrate with respect to x. Keeping what as constant? Nothing, because all other we bought as constant. So no issue. Directly I can see the variable x. So what is integration of x into dx? Cb is constant. So bc x squared by 2, limits are 0 to a, plus b square c by 2, integration of dx is x, so 0 to a, plus c square b by 2 integration of dx is x. So 0 to a. So what I get finally? So bc a squared by 2 plus b square c by 2 plus c square b a divided by 2. So I got my volume for this respective function. So if I take ABC by 2 out, I'll get A plus B plus C is the required volume of this problem. Okay, I'll go to the next problem. The second problem is evaluate. I'll make you to understand the function whenever it depends upon two variables, right? So evaluate double integral 0 to 2, 0 to 1, 4xy into dx dy, right? So 0 to 1, okay. So suppose, I'm taking 0 to 1, 0 to integration 0 to 2 out. First, I'm going to concentrate on x-axis. So I have to integrate with respect to whom? So x-axis, what to make it as constant? I have to make all the points along y-axis as constant. So with respect to x means I have to keep this y as constant. So 4 is already constant, y. So integration of x is x squared by 2. So limits already given. It is both upper limit and lower limit are constant, so no issue. So directly I can take the constant, right? So into whom? Into dy. So 2 get cancelled. I'll get 2 y out, 0 to 2, upper limit is 1, so 1 square minus 1 square is 1, minus 0 square is 0, so 1. So 1 into dy, so which is equal to, I'll take 2 out, 0 to 2 y dy, which is equal to 2 y squared by 2, 0 to 2. So 2 get cancelled, 2 square is 4, 4 minus 0, which is equal to 4 is the required answer for this double integration. Okay, next, so third problem, I'm going to teach you the change of order of integration, which is very important. Change of order of integration. Change of order of integration. The problem is this, and I have to evaluate. Okay, integration and evaluate. And evaluate what we have to evaluate. 0 to 4, x squared by 4, 2 root x, dy dx, dy dx, right? So I have to evaluate this. So after changing the order, what happens? Which is equal to double integral dy dx is given. So after changing the order, it will become dx dy. Okay, so dy dx is changed to dx dy, but limit won't be same. So but limit won't be same. We have to find the limits. Only then I have to integrate. Then only we have to integrate this. So for that I need the graph. By seeing the graph only we can find the solution for this problem, changing the order. Okay, so I'll go to the next slide and then I'll explain. Yes, so look into this, like, so double integral, what is given there? Double integral dx dy, right? Dx dy, it is changed to double integral dy dx. I'll draw you the graph here. X-axis, y-axis. What are all the points given in the given problem? Like y equal to what? So dy dx is given. Okay, so this is given and we have to find this, right? What is the limit of y? X squared by 4, 2 root x, 0 to 4, which means y equal x squared by 4 and y equal to 2 root x, comma, x equal to 0 and x equal to 4. So this is nothing but y square equal to 4x, which implies x equal to y squared by 4. X equal to whom? Y squared by 4. So which is nothing but a parabola along x-axis. This is nothing but a parabola along y-axis, like this, right? Okay, so this is parabola along x-axis, right? So y square by 4. The other one is x squared by 4. X squared by 4, right? This one is x squared by 4, right? Next, x equal to 0. This is origin 0 comma 0, and x equal to 4. X equal to 4 means which point? This point. But make sure that if x equal to 4, x distance is 4, what will be the y value? Y is also 4. You can see substitute root of 4, you will get 2 into 2, 4. So y distance is also 4. So I'll get 4 comma 4. Now time starts to find the limits of the function after changing the order. I mean this one. So what will be the limit of x? For that I have to draw the strip parallel to x-axis. I have to draw the strip parallel to whom? X-axis. One end is fixed here, the other end is fixed here. Okay. So in this end, I can see the value of x. What is the value of x here? What is the value of x? Y squared by 4. So I got one limit. What is the other end? This one. What is the value of x on the other end? So what is the value of x on the other end? One is y square by 4. Another one is, so 2 root y square by 4. Another one is 2 root y. Yes, where is it? Here. So x equal to what? 2 root y. X squared by 4 is y. So x equal to 2 root y. So I got it. So I'll write here 2 root y. Next, similarly, I have to draw the strip moving from lower bound to upper bound. So lower bound to upper bound, if I move, what will be the length? So at the lower bound, I can find 0. Upper bound, I can find the limit as 4. For whom? For y limit. I'm talking about y limit. In order to find the y limit, I have to draw the strip moving from lower bound to upper bound. So 0 to 4. Only in this way you have to find whenever you are changing the order. So this is the given problem. I am repeating again. So we change this problem to dx dy. So already it was in dy dx. Now dx dy. But limits won't be same. We have to find the limits by drawing the graph. Specifically dx dy means I have to draw the strip parallel to x-axis and see the endpoints of the limits. So I noted the endpoints of the limits. And then for x-axis, for y-axis, I have to move the strip from lower bound to the upper bound. I think everyone can view clearly 0 to 4. Now it's time to integrate this function. So 0 to 4, what is integration of dx? X. So dx x, y squared by 4, upper limit is 2 root y into dy. Into what? Dy. So which is equal to 0 to 4. So 2 root y minus of y squared by 4 into whom? Into dy, right? Yes. So next, so 2 I'll take it out. This is y power half. This is what? Y power half. So what I'll get here? Y power 3 by 2 divided by, if I integrate 3 by 2, right? So limits are 0 to 4 minus, I'll take 1 by 4 out. What is integration of y square? Y cube by 3. Y cube by 3. So limits are 0 to 4. So here 2 2's I'll take it out. So 4 by 3 I'll get. Here upper limit is 4. So 4 power 3 by 2 minus of 0 I'll get 0 only. So close it. Minus of 1 by 12 I'll take it out. What's the upper limit? 4. So 4 cube I'll get. So it is going to be 64. Okay. So here 4 by 3. 4 by 3, this is, I can write this as 2 square of 3 by 2 minus 64 by 12. Okay. So 4 3's, 4 16's. Yes, 16 by 3 I'll get there. So 16 by 3, which is equal to, here 2 2 get cancel. So I'll get 32 by 3 here minus 16 by 3, which is equal to 16 by 3 is the required square units for this double integration. Thank you. Sir, eவ்வளவு minutes